Hello everybody, getting ready to do lesson 9.4 of pre-algebra math, real numbers today. Part 1, part 2 is available here. 9.4, real numbers. We got a 36-point classwork sheet today. We got 10 points here of note-taking, students and teachers. Today's bell work. A ship travels 7 miles due north, then 20 miles due east, northeast. Explain how you would find the distance of the trip. So you want to find that. Students eating out at a restaurant, you choose a first course, main dish, vegetable for dinner. You can choose fruit or soup for the first course. For the main course, you can choose steak, chicken, fish, or lasagna. For a veggie, you can choose beans, broccoli, or carrots. Find the number of possible meals you can choose here. So okay, that's from your counting principles. That should bring you out there. It's, teachers give you students 6-7 minutes for this. This is a good one here. Okay, our solutions for today's bell work. Here is your hypotenuse here. 21 equals C equals that here. After figuring this in. And then down here, number of firsts, number of mains, number of veggies, total number of possibles. So there's 24 possible meals here. Number of firsts, number of mains, number of veggies. So you just multiply them together and you get 24 for that. Kind of a trick question. Okay, into our first page here in our classwork. In 5.1, you learn that rational number is a number that can be written as a quotient of two integers. All rational numbers have decimal forms that terminate or repeat. An irrational is a number that cannot be written as a quotient of two integers. The decimal form of an irrational is neither terminates nor repeats. For example, in the irrational number below here, look at that. The pattern of 1 separated by an increasing number of zeros continues without end. The decimal neither terminates nor repeats, so that's a fine example there of an irrational number. Real numbers consist of all rational and irrational, so reals contain irrationals too. The Venn diagram below shows the relationship among real numbers, so we have rationals over here, which contain integers, whole numbers, and then instead, teachers, you can write in more here. And then irrational numbers are of numbers where decimals are non-repeating, or rather they don't repeat or they don't terminate. So that would be irrationals. They're like pi, for example. Okay, into our first example here. In this situation here of classifying real numbers, we have a table, a cool table here, example 1. And then we have decimal form, we have numbers, decimal form, decimal type, and then type of number that it is. So we're going to go through and analyze some numbers here. So 5/8, that's the number. In decimal form, it's 0.625. Decimal type is terminating, it terminates here. And then the type, it's a rational. And then for B, 5/6, the decimal will be 0.83333. So it's what? It's repeating. So if it is repeating, it is rational. And then for here, square root of 19. Here is the decimal here, 4.358898494. It goes on. So it's non-terminating. And what does that mean? It's non-repeating either. Non-repeating, non-terminating. So it is irrational because of that. Tell whether a number is rational or irrational. Square root of 6, students, this is yours. So let's do our guided practice here. For square root of 6, here's the decimal. Decimal is non-terminating, non-repeating, so the number is irrational. So square root of 6 is irrational. Graphing irrationals, you can graph an irrational number on a number line. For instance, to graph square root of 2, draw a right triangle with one leg. So we got here square root of 2 here. This is the distance from the origin right here is square root of 2. So for instance, to graph square root of 2, draw a right triangle with one leg on a number line, each leg with a unit of 1. By a Pythagorean, the length of the hypotenuse is 1 squared plus 1 squared equals square root of 2, which is about here. And I think square root of 2 is what? It's 1.414, blah, 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 goes on. So you can use a compass to do that. I mean, that's kind of like a constructive way of doing it with a compass, is that you square root of 2 here, and then you can put that down onto a number line. You can draw a triangle here, stretch out your compass to this, and then bring your compass down. There it is there. Notice the graph square root of 2 is close to 1.4, so square root of 2 is approximately 1.4, which agrees with the decimal form of square root of 2, which is this number here, and it's not repeating, so that's what it is. Okay, students, vocab, irrational number, define that in your own words, and then real numbers, define that in your own words. 10 points, notebook, page 6 on lesson 9.4. Okay, let's get into another example here. Example 2, copy and complete. Square root of 2 is what to 9 over 5 using these symbols here. Here they are in a number line. Square root of 2, 9 over 5. So square root of 2 is to the left of 9.5. What does that, or 9 over 5? What does that mean? It means that square root of 2 is less than 9 over 5. Okay, copy and complete using these inequality, or you have an equal sign here as well. 15 over 4 is what? And 2 square root of 15. Students, this is yours down here. Okay, let's do our guided practice, 2 points. Independent is 4 points. So our guided here, this is your lucky day, students. Our guided is here. We put these on a number line. 15 over 4, square root of 15 is here. So 15 over 4 is less than square root of 15. Is it your lucky day, students? No. So that's 9.4, part 1. Part 2 is available here, as well as all of your other materials. Thank you.